Today we are going to be doing proofs, but a lot of people are, after yesterday's homework, get a little stressed and overwhelmed when now I say I'm throwing one more thing at you. I think proofs are a little bit easier because on yesterday's and the days before homework when you did them, you never quite knew if you were done. And you never quite knew if you had it correct unless you obviously checked your work. With a proof, they tell you where to start and they tell you where to end. So you kind of have a goal of what you're working to. And when you get to that goal, you know, I made it, I'm here. And as long as you've shown your steps, that's all that I need for these proofs. So for proofs, we must show our step or every step of our work. You don't have to say because of the Pythagorean identities or the reciprocal. You don't have to justify. Your work is your justification, okay? So to start, we're actually going to do an algebraic proof, not even a trig proof, just an algebra proof, so that you can kind of see how I want our proof set up. So we're going to prove that x squared minus 1 over x minus 1 minus x squared minus 1 over x plus 1 is 2. When you do a proof, you cannot move some terms from one side to the other side. That would be a solving problem. Proofs mean you start with one side and you keep manipulating that side until you get to the opposite side. When I start a proof, I try to start with the more difficult side because that tends to mean that there's more things I can do to that, versus if I start on what seems like the easier side, then I have to like make things up. Like if I started on the side that says equals 2, I have to somehow get 2 to equal these variables and these fractions, which I have to be pretty creative to come up with that. But if I start on this left-hand side, which is what I'm going to do, I'm just going to kind of draw a line down here to show that I'm working on just one side. If I start on that left-hand side, what I'm going to do first is I'm going to see if I can simplify those fractions and see if anything can reduce. Otherwise, I'll have to go ahead and try and get a common denominator, which I'm not going to do quite yet. In that numerator of this first fraction, that can actually factor. Does anybody know how x squared minus 1 factors? That is not a GCF type of factoring. It's not a trinomial type of factoring. It's a difference of two squares factoring. So x squared minus 1 can factor to be an x plus 1 and an x minus 1. Because if I were to FOIL that out, I'd get my x squared. I'd get a negative 1 plus 1, which would be 0, those cancel, and then a minus 1. That is all over that. I guess I shouldn't have drawn that line because I wrote way too big. This second fraction is going to be similar. And give myself a little more space, sorry. I'm going to factor that, x plus 1, x minus 1, all over x plus 1. In this first fraction, even though it looks more complicated, are there any quantities that we can cancel? Yeah, I can cancel the quantity x minus 1 with an x minus 1. That would leave me with just x plus 1. And then there's this minus sign in between the two fractions, so I'm going to put that minus sign. In that second fraction, is there any quantities that cancel? Hopefully you see the x plus 1s can cancel. So that leaves me with an x minus 1. Some people ask, do I have to keep the parentheses? You do and you don't. This first one I don't have to because in front of it there's no sign, which means it's a positive sign, which means I'm not changing anything. So that one is still x plus 1. The second one I had to keep those parentheses there because I have to make sure I'm taking the opposite of all of that, which means I want a minus x, but then when I take the opposite of a negative, that would be a plus 1. And then I've got an x with a negative x. Those cancel. So that leaves me with 1 plus 1, which is 2. That's what our goal was. We wanted it to equal 2, so I can just put a check mark saying, there's my proof. So never once did I have to do a justification step. Never once did I move anything from the right side to the left side or vice versa. So you have to keep working one side until you get there. That's the type of work that I want to see when you're doing your proofs today. Okay, so there's one step after the next step, so it's easy to follow. You can go like we did, where it's a vertical proof, where it's right below it, so it's easy to follow. Some of you I've noticed on your homework, you kind of show your work left to right. That's fine as long as I can tell here's my next step. So you might want to put like equal signs here, or if you're doing it vertically or horizontally, you might say, well, that leads to this step, and then that leads to this step, just so I can tell where your separate steps are. Okay, okay, so we are going to try trig proof now. So we want to try to prove that tangent of x plus cotangent of x equals secant of x times cosecant of x. When I start a proof, I have to decide if I'm going to start on the left-hand side or right-hand side. I try to start, I told you, for the more complicated side. When you look at these, does one of these look more complicated than the other one? I mean, they both have two trig functions, and they both have not sines or cosine trig functions. I would honestly argue, though, that the left side looks more complicated because the left side has two separate terms versus the right side is just one term. So I'm going to start on that left-hand side as I take a drink of water. I want you to switch everything on that left-hand side to sines and cosines. So do the first step. When I start, I'm going to try to, not every time, but a lot of times if I'm not sure where to start, I start by changing them to sines and cosines. So I know a tangent would be sine over cosine. I know cotangent would be cosine over sine. If you're adding two fractions, what do you have to have? Common denominator. I don't have a common denominator. What could my common denominator be? Yeah, sine x times cosine x. I can just take both of them. So that's what I'm going to do. I'm going to multiply this side, top and bottom, by sine x. I'm going to take this side, top and bottom, by a cosine x. That's going to give me my common denominator of a sine x times cosine x. And in my numerator, sine times sine would be sine squared. Cosine times cosine would be cosine squared. Anybody see something we can do now? Specifically with that numerator? Sine squared plus cosine squared equals 1. I can't cancel, just a quick heads up, like a sine with the sine and a cosine with the cosine because of that plus sign. If that was a times, absolutely I could start canceling, but since it's a plus sign, those are separate terms. But I can say that that whole numerator equals 1. It's not quite in the order I want, but it's okay. We almost have our answer right here. If you had 1 over sine, what is 1 over sine? Cosecant. And technically, you don't have to show this step, but I'm going to show you. If I wrote the numerator as a 1 times 1, it would still be 1. What is 1 over cosine? Secant. I get it's in a different order. This says secant times cosecant. Here I have cosecant times secant. I would tell you that that is close enough and we are good. Because if I were to take like 2 times 3 versus 3 times 2, it's not going to change anything. We have that commutative property, so we're good enough. So let me put these things aside. So if you just have a 1 over all of that, you can say, well, 1 over sine is that cosecant, 1 over cosine is that secant. You can reuse that 1 because they're both located in that denominator. Okay. So just a few hints that we've kind of talked about already, but when you begin, you want to begin on the more complicated side. Sometimes there is not a side that looks more complicated, so you just pick a side and start on that side. If you ever get stuck, try switching everything to sines and cosines. Sometimes that means switching it to a sine squared and a cosine squared, but if you ever get stuck and you're like, I don't know what I could do, try switching it to sines and cosines, because then maybe we could get a common denominator, or then maybe we could cancel something. And if you have fractions, you want to simplify first and then get a common denominator. Once you've got that written down, turn it over to the back, and we're going to try the last two examples. And hopefully we'll still have some more time today, or if you have more questions from yesterday, we can go over more questions from yesterday. Example 3, as you are flipping it over, of course I have to switch it up as soon as I give you hints for proofs. Example 3, I think there's a couple questions in your homework today that actually say, does this equal choice A or does this equal choice B? So our answer is either A or B when you flip it over to the back side. There's not a lot like this, but I wanted to make sure you had one like that. So we have to start with the 1 over secant of x minus 1 plus 1 over secant of x plus 1. So I'm going to erase all this so that we can continue. So I'm going to start with these. We've got two fractions, and I just told you for your two fractions, try to simplify first and then get a common denominator. When I look at this, don't write this down. The only simplifying step I could see is if I try to switch everything to sines and cosines, I'd have that, and then I'd have a fraction within a fraction. Does that make it look any easier? Yeah, don't do that route. Okay? So you can look for it and be like, that does not look like a road I want to go. What I'm going to have to do for this is I'm going to just try to get a common denominator right away. I don't like how I have it typed, so I'm going to write it out real quick. I'm going to try and get a common denominator right away. It's kind of like one that we did earlier today. I'm going to just multiply that first fraction by a secant of x plus 1. And I'm going to multiply the second fraction by that secant of x minus 1. And I am going to FOIL out that denominator. Take a minute right now, multiply out that denominator. It should be a difference of 2 squares pattern, so terms should cancel. So see if you can multiply that out, and we'll see if we get the same thing. So if I FOIL out that denominator, I'm going to get a secant times secant, which is secant squared. I will have a minus secant, but then a plus secant, which cancels out. And a 1 times negative 1 is negative 1. In my numerator, I'm going to have a secant of x plus 1 plus a secant of x minus 1. So I'm going to cancel some terms. 1 minus 1. And I'm going to replace that secant of squared minus 1 with something. What can I replace as secant of squared minus 1 with? Specifically, whenever I see any squareds and ones, I immediately look at Pythagorean identities. Is that tangent squared? So I'm going to say my new denominator is going to be a tangent squared. My numerator is actually secant plus another secant, which actually means I've got 2 of the secants. I mean, we're not done yet, but I can spot check. Does it look like we're heading towards choice A or choice B? Anybody have any guesses? I would guess A because of that 2 out in front there. And there's a 2 secant. I'm not positive, but that's where I'm leaning towards. I am kind of stuck. So I'm going to switch everything to sines and cosines and see if that gets me any closer. So this would be 2 secant, technically I can write it like this, 2 times secant is 1 over a cosine is being divided by tangent squared. Tangent is sine over a cosine, which really means I got 2 times 1 over cosine times cosine squared over sine squared. I evidently write way too big. I can cancel a cosine. This was a cosine squared, so I can cancel it with just one of the two. So I'm just going to cross out that square. I've got a 2. That next thing right here is gone, and I've got a cosine over sine squared. In either of these answers, do we have anything that's being squared? We don't. So I'm going to write this one way just to see if this will help us. I'm going to say I've got a 2 times this fraction with a cosine on the top. And instead of writing it as sine squared, I think it'll be more obvious if I write it like this. Because then I can say this. What is cosine over sine? I've got a 2, I've got a cotangent, and I still have the sign that's left in the denominator. What can I write that as if it's the sign that's left in the denominator? That's like a 1 over a sine, which would be a cosecant of x. So for this one, we'd have to go with that choice A. Okay, one more, and then we'll have some more time. So our last one is a proof. Good news for this last proof. They're all sines and cosines, so hopefully that means that it's going to be a little bit easier. Okay. When you look at that last one, which I'll move up in just a second, I know some people are still writing. When I look at that last one, and I'm trying to decide which side is the more complicated side, I would say the left side is more complicated. Because with fractions, if I can have one term in my denominator, to me that's easier than having 2 terms in my denominator. Does that guarantee it's easier or more difficult? No, but I'm going to start with the left-hand side. And honestly, for example 4, I don't know if it's any easier to start with the left versus the right. Okay. So I'm going to start on that left-hand side. This is one where we have to resist the urge. Since it is a proof, I cannot move anything from the left side over to the right side. I have to, if I'm starting with this left side here, I have to keep working that left side until I get it to turn into that right side. Okay? I do a couple things here. Because it's a proof and I know where I'm trying to go to, I don't want to say cheat, but I'm going to look at that right side to help me. If I look at that left side right away, I honestly don't have any obvious, here's what I would do to start. So what I'm going to do on that left-hand side, I have this cosine of t over 1 minus the sine of t. I'm going to multiply the top and the bottom by something. And it's not something that we would just naturally come up with. So I'm going to show you what I'm going to multiply by. I'm going to multiply by a 1 plus sine t on top and bottom. Because if I multiply the top and the bottom of a fraction by the same thing, that just really means I'm multiplying by a factor of 1, which means I'm not really changing that fraction. The reason why I picked the 1 plus sine t, there's 2 reasons. Now my denominator, if you FOIL it out, that should be that difference of 2 squares pattern that we've been talking about today. That should multiply out really nicely for us and hopefully lead to a Pythagorean identity. And the other reason why I chose that is honestly, I looked and in my final answer, I want a 1 plus sine t in the top, and that will force it to have a 1 plus sine t in the top. So there's a couple reasons why I chose that. Because I want that 1 plus sine t in top, I'm not actually going to multiply out the numerator. I'm going to try and protect that 1 plus sine t in the numerator because I want it to end there. In my denominator, if I FOIL that out, that's going to give me a 1, a minus sign, but then a plus sign, so they cancel. and I get a 1 minus sine squared. Hopefully there's a bell going off in your head saying, look at your Pythagorean identities. What can I put in place of 1 minus sine squared? Cosine squared. Okay, so I've got my numerators remaining the same. In my numerator, even though I've got that parentheses that has a plus sign in it, it is a term times a term. It's a multiplication statement. And if it's multiplying, I can cancel, which means I can cancel a cosine with a cosine. And that would leave me with 1 plus sine all over cosine, which is, I believe, what we were trying to get to. Okay. People in the past have asked, is that the only way? That's not the only way. There's a lot of these are more than one way. So as you work on these, if you get stuck or if you compare your work with somebody else, or if you ask myself or Mr. Cloud to look at your work, I might know a different way that I've done it in the past, but I will most likely look at your way to see if we can continue with your way to get to that same point instead of saying erase everything. So that is it for notes today. I'm going to stop this recording real quick.